You know that feeling when you finally decide to upgrade your 3D printer, you find a cheap continuous belt model on a marketplace, click buy, and a week later you're staring at a belt that drags, a nozzle that constantly clogs, and a print that never quite reaches the length you imagined? I've seen that regret play out a lot in the hobby community. People trade a modest price for a promise of infinite prints, only to end up with a machine that spends more time being fixed than actually printing. That's why I wanted to take a closer look at the IdeaFormer IR3 continuous belt 3D printer before anyone throws their money at the next low-cost alternative. Link is in the description if you want to check the product details on Amazon. The first question most of us ask is whether the extra hype around infinite axis really translates into a practical advantage, or if it's just a marketing gimmick that ends up costing us time and space. The IR3 V2 claims a 250mm print area on the X and Y axes, but the belt extends indefinitely on the Z-axis, theoretically letting you print anything from a 5cm phone case to a 2-meter architectural model without stopping. In real-world terms, that means you can set a single job to run overnight and wake up to a continuous, uninterrupted part, no need to splice together sections or manually rehome the printer after each layer. For people who actually need long parts, think custom drone frames, cosplay armor sections, or even small-scale production runs of interlocking building blocks, that continuous capability can shave hours, sometimes days, off the workflow. What makes the IR3 feel like a smarter buy compared to the cheaper belt printers is the combination of 3 smart features that most budget models skip. First, the auto-leveling system is built into the frame and runs a quick calibration routine before each print. I've tried a few belt rigs that require you to manually adjust 3 screws every few prints, and it's a pain that often leads to a warped first layer. With the IR3, you press a button, the printer probes a few points on the PEI-coated metal belt, and it adjusts the nozzle height on the fly. In practice, that means the first layer sticks consistently, even if the belt has been running for hours and has a slight sag in the middle. Second, the belt itself is a metal strip coated with PEI, which gives you a flat, high-adhesion surface that tolerates a wide range of filaments, PLA, PETG, TPU, even some flexible composites. The metal core eliminates the stretch you sometimes feel with rubber belts, so the dimensions of a long print stay true over its entire length. In a test I ran with a 1.2-meter long prop rod, the final dimensions were within 0.2 mm of the CAD model, which is impressive given the length. The downside is that metal belts are heavier, so you'll notice a bit more motor noise when the printer is moving at its top 400 mm per second speed, and you'll need to keep an eye on the belt tension over time. Speaking of speed, the IR3 advertises up to 400 mm per second, and that's not just a number on a spec sheet. When you're printing a batch of 10 identical phone cases, cranking the speed to 300 mm per second can cut the total production time in half compared to a standard Cartesian printer stuck at 60 mm per second. The trade-off, however, is that you need to fine-tune your slicer settings, especially retraction and cooling, to avoid ringing artifacts at those velocities. If you're a first-time user who just wants a few hobby prints a week, you might never push it to that extreme, but the headroom is there for anyone who wants to scale up. Another practical convenience is the smart filament monitoring. A tiny sensor watches the spool diameter and alerts you when you're running low. On a long continuous print, that can be a lifesaver. You're not stuck watching the printer for hours only to discover the filament ran out at the 30-minute mark. The system pauses the job, saves the state, and lets you load new filament without ruining the part. It's a small feature, but for people who treat their printer like a minifactory line, it adds a level of reliability you rarely find on budget kits. Now, let's talk about the real-world downsides that you'll bump into once the box is opened. The first one is size. The IR3 sits on a floor space of roughly 600 mm, and you need a sturdy table to keep vibrations in check at high speeds. If you live in a small apartment or have a cramped workshop, finding a spot for this machine can be a challenge, and the belt itself needs clearance on both ends to roll out. It's not a desktop printer you can tuck under a desk, it's more of a dedicated station. Second, the belt maintenance routine is a bit more involved than swapping a print bed on a regular printer. The metal belt has to stay clean, and the PEI coating can wear over time, especially if you run abrasive filaments like carbon-filled nylon. The manufacturer recommends cleaning the belt